So hello and welcome to, I have to read it, Applying DevOps to the Modern NFV Factory. I think just walking on it, I just realized this is the third, in my career in telco, this is the third generation of factory I think I've been involved in. There was Servco, Netco, when I was in an operator. There was NGN factory, and now it's the turn of NFV, I guess. But the ambition and goals for building a factory in a telco are always the same, or for any factory for that matter. But in particular for enterprise kind of services that you're delivering. So it's how do we have a predictable cookie cut, predictable probably is the biggest word, way of delivering and maintaining services so that the costs are under control but are predictable, right? So if I sell 4 of these things, the costs are predictable. If I sell 1,000 of these things, the costs are predictable. So given that NFV is either software programmable or by definition software programmable or delivered as a lump of software, the level of automation that we should be able to achieve in this next wave of factories should be greater than anything we've been able to do in the past. So that's kind of the whole point of the presentation. And then DevOps is a key piece for us to we believe to be able to deliver this whole promise, right? So first, who are Accanto? So we're a software technology company, and our mission in life, I guess, is to provide tools that help automate the full life cycle of these new wonderful kind of network services, NFV-based network services. So if you look at I think Gartner invented this kind of infinity loop that describes the various life cycle tasks, or DevOps tasks, I guess, involved in delivering any kind of system or service in our case. But on the left-hand side, there's a whole bunch of onboarding, design, test tasks that any lump of software or any product or service needs to go through. And on the right-hand side, a whole bunch of operational tasks that need to be performed once things are in production. So the whole kind of raison d'etre for our software is to manage all of these tasks in a much more automated way than we've done in the past. And in particular, we started, and I've scribbled out the word orchestration kind of deliberately. So there's been a lot of kind of talk in the industry about orchestrating VNFs, I would say, into life. So kind of turning things on, and then the traditional role of provisioning or orchestration in the past is its job is now done. Once I've turned it on, I'm going to leave the building, and somebody else has to figure out how to maintain what I've turned on. So our goal is really, we started working on how do we automate the right-hand side, so the operational use cases that you have the complicated stuff, I would say, that you normally throw people at. So how do I automate after I've turned on a service, not just a VNF, after I've turned on a service, which could be quite a large collection of VNFs, if something breaks, or if I want to change the shape of that service, normally I need to throw an army of people at it, right? That's the telco kind of model that's been required in the past, right? So the whole point of our system is how do we breed a level of automation into a new tool, a new way of bringing these services to market, so that we can bring a lot of automation across that service life cycle, right? Which again can be a whole bunch of VNFs underneath. You see IBM's logo. So DevOps is so in the enterprise IT space, the DevOps kind of movement, I would call it, has been kind of very successful, right? So automating that continuous process where you bring new changes into software, in that case, test them automatically, bring it into production automatically. If something breaks, you kind of, there's a feedback loop back into that development cycle to get it back fixed and back into production. So our goal is not to reinvent any tools as much as possible to allow the kind of telco industry to benefit from that same movement. So with IBM, we've spent a lot of time leveraging what's already there and integrating this kind of telco, I'd say virtual networking kind of tool set into that chain. We set out about 3 years ago to build this kind of new piece of technology, and it's now in the field, kind of proving its worth, if you like. And some of the value statements we're getting back are cool, right? So we're seeing things like multiples. In this case, it says 30x times less effort required to manage that ongoing maintenance of a service once it's in production, right? And because of the way our system works, it's a lot easier for you to then model services and get them into production also. So I'll talk about this kind of stuff as we go through. All right, so what's DevOps? And this is kind of, hopefully I'm not teaching you too much how to suck eggs, but it's important, I think. So what's DevOps for this virtual networking world? What does it look like? Well, the obvious kind of first step is you onboard some software from a third party that delivers an appliance-like function, right? And then some engineer in an operator or wherever assembles that into a service that makes sense for his end customer. And then that gets tested as a collective, or needs to get tested as a collective, to make sure it delivers what it says on the tin, and then gets deployed in production, right? So typically, this all looks really easy in this kind of slide, right? Once in production, there's a whole bunch of feedback loops that the industry keeps talking about to self-optimize and heal or whatever the job is, that service that's been deployed, right? When things go wrong, there's a set of diagnostics that need to be performed on this service that then feed back into this DevOps loop, right? So at a very high level, this is what we're saying your new operating model needs to be for virtual services or products that are based on virtual technology, right? And there's a lot of talk of we call these personas Jack and Jill, and if you were here last year, you'll have seen these guys jumping around the stage. But the relationship between operations and design, or engineering in this case, is becoming almost the same role in some cases, right? So when a problem is found, as the DevOps movement has kind of proven out in IT, the engineering community are the ones who directly get involved in kind of resolving that problem or diagnosing that problem, using automated tools to help them do that. So in our roadmap, Jill on the right-hand side disappears, right? So level 1, level 2 operations people that you have today looking at tickets and figuring out how to get an army of people to log on to an appliance, that job must disappear, right? Because of the complexity involved in these new wave of services, right? And support becomes something almost embedded within the engineering process. That's the vision, right? So that's our vision. I would say it's the business case that comes with that, so that the operating cost model that comes with that is required, right? The vision I've got for the operating model is one thing, but if you don't achieve the cost model that comes with it, you won't be able to bring one of these things to market. The complexity is just too much. All right, so very high level, and I'll go into some of these in more detail in a minute. So what tools do we have then to kind of help that process become more and more automated that we saw on the previous slide? So one of the key pillars of what we offer is called an intent-based orchestration capability. Now, I keep saying this, we genuinely thought we invented the term intent-based everything, and all of a sudden it's kind of a thing, right? Which is a good thing. So what this means is similar to a sat-nav, rather than programming all of the life cycles involved in bringing a service into being, and then programming the life cycles that heal it, and programming the life cycles that change it in some way, or optimize it, move things around for cost reasons, for quality reasons, whatever, we must have an engine that removes that burden of programming from Jack and from Jill when things go wrong, right? So in the same way a sat-nav, you tell it what, the end destination you need to go to, our intent engine it behaves in exactly the same way. So you tell it what state you want the service to be in, and it figures out how to get you from where you are today to where you need to be, taking into account whatever the state of the environment is you're in. So if some bits are broken, we'll figure out how to fix it. If you want to upgrade bits of the service, we'll figure out how to do that and get you to where you need to be. And we call that's quite a mechanical tool, so that this comes with a cost. You have to force your VNFs, I would say, to comply with how this engine expects them to behave, right? So it's not a magic wand per se, right? But once you've forced your world to look like this, there's a massive amount of automation that you can get out of the box, mechanical, brutal kind of automation, right? By simplifying, by organizing, we force degrees of freedom to be removed from how you do things so that you can achieve this kind of level of automation. So building on that, then we have a set of tools that allow us to very quickly run behavioral tests on the thing or the network service that you've stood up, whether in production or in that test environment. I'll go through this in a minute. The cool thing about the testing story is really it's removing the operational errors that you'll see once you're running all these kind of workflows that our system figures out for you. And finally, this is kind of our homage to AI stuff, right? But this is quite cool in that. So far, through mechanical methods, I can get you. We reckon 75% automation, whatever that means, right? But there's about 25% edge cases that we can never really automate through mechanical means, right? So for example, all the lights are green on the VNFs and the services that or the infrastructure that deploys those services, but the customer's still having a bad time, right? So how do we, which means the VNFs haven't been programmed yet to report the right level of errors, or the assurance systems haven't been reporting the right level of errors, or whatever. So we now need to automatically go diagnose these edge cases. And if we can use, and this is, I would say, work in progress, but we are investigating, and we think there's a lot of opportunity for machine learning in diagnosing and self-diagnosing issues, and whether you let that self-heal is another kind of philosophical question. But these three things then get you to as close as damn it to lights-out operations is what we're calling it, right? That's the goal. Very quickly, I think I've already kind of said some of this stuff, but I just wanted to go in more detail to the three kind of key capabilities. So the way the intent engine works, and you can come by the booth and see demos for this kind of stuff now, right? But the way it works, we've got a standard lifecycle for that we've open sourced with IBM that forces VNFs to look, or any software appliance that we are managing, or physical appliance for that matter, it forces them to behave and look in the exact same fashion. So they all have an install, start, stop, configure, whatever kind of lifecycle action it is to manipulate these things. And our system then, so that requires work. So we need to map this lifecycle down to a set of device commands. Once you've done that, it's a one-off kind of job. We then have a building block that we know will look and behave like all other building blocks that are under our management, right? And the job of the engine, once we've got things in a kind of steady state, we then apply what we call opinionated patterns on top of these building blocks. So basically what we're trying to do is productize every operational situation that will ever occur for a network service, which sounds kind of super complicated, but once we've removed a bunch of degrees of freedom, and once things look all the same, it's actually quite an achievable set of patterns. So what we're doing then is, the smarts, I guess, is to use those patterns and based on where your network service is today, figure out the delta between where you need to get to. So that's the kind of the crown jewels from our point of view. And there's a really cool demo you can go see on the booth, which shows you this engine figuring stuff out on the fly. So because of the standard life cycle, it's a very simple, compared to some of the stuff I've seen from other bodies, a very simple integration method. It's easy in a week or 2 weeks we can fully integrate an appliance that doesn't have any kind of life cycle front end, right? So the effort to bring new VNFs into the system is quite small. And the whole role of how you program the intent engine is literally by modeling dependencies between these life cycles of things, right? So you don't write any code, any workflows, any scripts, anything like that. The engine's job is to do that kind of for you. And one of the really cool benefits of this approach is when things blow up, either in our system or outside of our system, getting our system back into a state where we can continue to manage it after we fix the problem is we just run what we call an intent again, right? So it knows that bit was broken, it brings the whole system back into life very quickly. This means when things go wrong, if you need any manual effort to fix the problem, it's really, really short. Like the time to repair and get the world back into an operational setup, goes from days to an hour, depending on the state of the problem, right? Okay, I'll fly through some of these. So behavior-driven testing is a cool. So now that we've got the intent engine, this is getting really cool in terms of what you can virtualize. But we can use the intent engine to spin up pre-production environments on a cloud, on IBM's cloud or Amazon's cloud or whoever, right? So we can, I saw a whole bunch of presentations that everything is virtualized now. So I can have open flow switches that are running virtualized with SDN controllers, with full-blown kind of VIMs running virtually. So we can very quickly spin up a pre-production environment, either for an individual user or something that represents the real world in an automated fashion, right? And then we can deploy a service onto that, and then we can test it without any humans being involved, other than submitting code or a new design or a new model for the thing you're trying to bring to market. This is a really, really big deal, right? This kind of service behavior, not VNF testing, service behavior testing, where we deploy probes that listen to traffic, deploy traffic generators, spin up the environment. Doing that in an automated fashion is quite a big deal, right? Cuts down on time and means you can scale the system. I think I'm talking too much, so I'll click on quickly. The AI story, and we're working a lot on this at the moment. So in the situation where, again, all the lights are green and something goes wrong, we've got a bunch of use cases, in this case with IBM's Watson, where that same service behavior test you saw a minute ago, Watson can say, a customer's reported a problem, or some system has reported an anomaly. I'm not sure it's a problem. I'm not sure there's a system error or VNF error or whatever it is, but in this case, Watson can request of us, can you please run a diagnostic? Now, all that means is we're running the same kind of test that we did in kind of pre-production, right? So we're injecting traffic, we're putting probes into place, and we're generating a whole ton of debug. That's really the kind of point from our perspective. But we're doing that on demand, and we can turn it on and off. And that's pretty cool, right? So Watson can say, give me a general diagnostic that will turn on debug here. It might spot a pattern that says, okay, there's an anomaly over there, give me a more targeted diagnostic. And basically, it proactively keeps knocking on doors until it finds an actual problem, right? And then it heals it, or it asks us to heal it. So again, this is, I was going to say it's futures, but it's not, right? I mean, we're working on this now with customers. All right, so I'll go through this quickly. What I wanted to show you was applying this to a real example that we've been working on. It's a B2B example. I think VCPE, or whatever you call it, enterprise connectivity, has become the first real solid business case that's getting rolled out. So in honor of that, this is one of those. But so our tools are running in this case on-prem for an operator. They can happily run in a public cloud if that's something you want to do. But in this case, we onboarded, I think, firewall, DDoS, some tools like test tools and so on. So the service we're going to see is virtual CPE or unified CPE deployed to a branch office with, I think there were 3 VNFs per site, and scaling quite largely from, in this case, from 5,000 sites to, I think, up to something like 100,000. That's the prediction, right? But we onboarded the VNFs I think each VNF was something like 7, on average, say 7 or 8 days, right? And these are tools, these are pieces of software that were never given a pretty front end or a pretty life cycle for us to just magically suck into the system. So we had to do some work to get them into the system. Once we'd done that, the next job is to model the service, not to write any workflows or any scripts. That's kind of been done in the onboarding stage for the VNF. So what we do is model types of locations. So these are branch office locations. These are others, right? So this is your headquarters and stuff like that. And where the various VNFs would be deployed and how they're related to each other to deliver what kind of service, right? The whole point And we can get into a lot more detail on demos on the booth, or if you're interested. But the whole point is you've not written any code, right? Or any workflows or any script, anything that can go boom in operations and cause chaos for multiple people to fix in numbers of days. You've removed all of that kind of risk of things breaking. And this is a picture of our UI that kind of you use to model that. So now that you have a design, you can instantiate a service, and I've trivialized the kind of somewhat. But what you're seeing on the top left, now we're going to bring it into life, right? And on the top left, what you're seeing is inside the intent engine, this is the process or the execution plan, we call it, that gets generated on the fly. So all we ask this thing is, or all we tell it is, I want this service to be brought into a state of active across these locations, and it figures everything out, right? And in this case, it deploys VMs, so just normal kind of stuff. But more importantly, it starts to, the relationship model you saw very quickly at design time, drives the instantiation of a whole bunch of relationships across this world, right? So start this one first, then pass the IP address of that one to over there. Just really kind of simple stuff, right? But there's the more appliances you have that have dependencies between each other, the more important it is when either something is instantiated or something blows up, that you maintain the dependencies between the appliances. It's kind of a complicated sentence, but it's dependency management. It's what a network is, right? So that's cool. We've set up the first service. The customer now wants to add some sites, and literally we go back into the intent engine and say, bring me into a state of active again, but with these additional changes to the description of the service. And what's cool here is we've deployed so we've figured out, here's what the service looks like, here's where we need to be, which meant deploy some new VMs at those locations, and then wire back up any dependencies into the existing world that are needed, right? And you'll kind of see a pattern. And these are kind of naughty examples, but you get the point. So this case is if something blows up, right? So in this case, a VNF has told us it's broken, right? Which is kind of the easiest case. So again, we spot that, triggers a policy, and we ask the intent engine again to bring the service back into an active state. And what happens, we basically bonk the VM on the head, right? And more importantly, when that, which is the brutal automation, brutal love kind of story, but more importantly, when that VM comes back up or when that service comes back up, we need to share all the changes that have happened, if any, with all of the things that are dependent on it, right? This is a really simple example. There's only 5 sites, right? A typical bank would have 2,000, right? A telco will have many banks. I think that's my next slide, right? So this is all great with this level of complexity, and even on here you're not seeing it, but a typical enterprise will have, a small enterprise would have, tens of sites, but a big bank, or if you take, I don't know, Starbucks or something, right? You're talking thousands of sites, and potentially complicated services between the different entities within that bank. So with our system, we not just believe, we've proven that using the tools from the world of managing physical appliances and the same operating model that you have for physical appliances does not scale, right? The cost model just goes out of control very, very quickly. And with this approach, and of course with our tools, but certainly with this approach, the whole point of it is that the cost model is maintained at a predictable level, which is kind of a fundamental tenet of the whole business case for NFV, certainly for all of it, but certainly for enterprise, right? I'm 4 minutes over time, and I haven't been hooked off the stage yet, which is pretty cool. But and I'm not going to go through this much, and it should be kind of obvious now. But so the whole point of this system is automate as much as you can at that scale operational level for the humans that are still involved, right, in the system, and are very importantly involved in the system. We dramatically increase their productivity. And all of this means that you can, at a more predictable level, generate more products, more services at a lower OpEx, at a predictable OpEx than you could with traditional tools. And I think that's it.